Hello everybody, my name is HaleyVien, and in this video I will be presenting the proof I made in Ms. Lopez's geometry class, which contains conjectures on triangle congruency and CPCTC. So we will be using different colors to represent our different givens. For the first line, we will be using green, and the line says that line segment BG is congruent to line segment IG. And those two lines are located here, IG there, BG here. So we will be marking those with green. Second line says that line segment CG bisects line segment AH, and we will be corresponding this given with the color purple or magenta. And so where we will find these lines, so we will mark these lines as congruent since CG bisects the whole line on the right, which means that it is split in half. So, and the next one is that line CG bisects angle JGF. We will be using the color dark blue to represent this given. As you can see, CG is there and JGF is here. So since CG bisects it, then these two angles must be congruent. And our fourth given is that line PK is parallel to line AH. And so we'll be representing this with black and these two corresponding arrows. The next given is that angle AJP is congruent to angle HFK. So AJP is there and HFK is here. We'll be using the color pink to represent these congruent angles. And so the next line we will be using the color red to represent it. So let me get the red. And so it says the angle FGH is congruent to angle JGA. And so since they are congruent, we'll need to find the points. So points are FGH is there, so we can mark that as red. Now I'll put double line to know the difference. JGA is there also, so we'll also do the same markings, the same color. So now that we have all of our givens on our diagram, then now we can start working on actually proving stuff. So first we will be trying to prove, oops, sorry, that was a mistake. We will first be trying to prove triangle GFH is congruent to triangle GJA. So to figure this out, we will need to know which other angles will be congruent, or any sides that will be congruent for these two different triangles that I will be coloring in yellow. See, these two triangles are being colored in yellow to show how they must correspond to each other. So since we know that angle FGH is congruent to angle JGA, then that means we already have one angle down for figuring out the congruency for these two triangles, for these two larger triangles. We also know that lines HG and AG, are the same since CG bisects AH. So since we know both of these, then we just need one more angle or side to show congruency. And by the alternating interior angles conjecture, we can show that these four angles are all congruent to each other since both lines are parallel that they are formed with. So that means that we have an angle, a side, and another angle to show that these two triangles are congruent, and that shows us the angle side angle conjecture that proves congruency between different triangles. As you can see, angle, side, angle. So since we finished that, now it is time. Now we can color that in as yellow to show that we've already proven them as congruent. To further show that these triangles are congruent, I'll be writing the congruent signs on both triangles just to remember later on. That will be part of our next steps in figuring out the line segments JC and FC. Let me just fix B. So now we're going to figure out JC and FC. So these two lines that are very small, we will have to figure out how they are congruent to each other through the use of these now congruent triangles and the rest of the given statements. So now, as you can see, these two lines and these two angles are congruent to each other, as we've seen from the givens already gotten. So from here, we need to figure out one more angle, or at least one more side, that will prove the congruency of these two triangles. And since these two triangles share a side, by reflexive property of congruence, that the side CG should be considered congruent to itself. So that means that the triangle already has two sides and an angle, which will give us side, angle, side, and for the other triangle, side, angle, side as well. So that means that these two triangles have been proven to be congruent. So side, angle, side again, just to show emphasis on that. Now that we have proven that these two triangles are congruent, now we can finally try and find out if JC, or prove, that JC, the line JC and line FC are congruent. So to figure this out, we will need to use the bigger triangles we solved to be congruent earlier and the ones that we just used now. As you can see, the line that is marked in green, the lines that are marked in green, are congruent to each other. And since line FG and line JG should be congruent as well, since they are part of the bigger triangle. And by the additive property of length, line segments BG and IG should add up with line segment JI and FB to be the same, since FG and JG are congruent CPCTC. So now we know that one side of the smaller triangles, the smallest triangles, are now congruent to each other. Furthermore, with the triangles CIG and CBG being congruent to each other, that means line segments CI and CB are congruent to each other as well. Because of the emphasis on the congruency on these two triangles, of course we will have to use at least one more element from them to prove that line segment JC and line segment FC are congruent. We will be using angles CBG and CIG to prove that triangle JIC and FBC are congruent. And so by supplementary angles, we can show that angles JIC and FBC are congruent, since when these two angles add up, they both will equal 180 degrees, which is pretty much the definition of supplementary angles. So now we have a side, an angle, and a side for both triangles, which proves that they are both congruent. And since they are both congruent, I'll fill them in to show how they are congruent. Then that means that line segments JC and line segments AFC are congruent by CPCTC. And so this is pretty much the end of my proof. At the end of the video, though, I will be showing a written statement and reason chart of how the proof should look if it were to be written down in this kind of form.